Good morning. How are you doing, guys? After 2 weeks, or you have another? We have one tomorrow. Okay, best of luck. Any questions? I think there are some students. Aidan, you and there are two more students. If you want to review your exam, not exam, quiz number 1, I don't mind to review it. Okay, is it with you right now? Okay, after class, come to me. And students who want me reviewing your quiz number 1, please come to me today or on Monday and Friday. I have a meeting. I have to leave, so I won't be available in my office. So either you come today or on Monday. Okay? Okay. I'm going to talk on two-port circuits. Today's lecture is quite simple. It's not difficult at all. So why do we need to learn two-port circuits? Sometimes you see a network like this, and we call it two-port network. As you can see, there are two terminals as input over here, A and B, and two terminals as outputs. You see C and D. A current I1 is entering. This is the reference direction for the current, and this is the reference polarities for V1 and V2, and I2 also is entering. So there are, whatever you see, there are reference direction for currents and polarities for voltages. So we have two voltages, V1 as input and V2 as output, I1 input current and I2 output current. So we call this part, the left side, input port, and the right side is output port. So sometimes we have a circuit like this, that we have a network, and we are interested in relating the current, as you can see over here, and voltage at one port to the current and voltage at the other port. So that's why we use two-port circuits. Clear? So this is the network or the circuit in the time domain. So if we convert it to the S domain, we get this circuit in the S domain. So we have 4 terminal variables. So only 2 are independent. I will explain it further later. So once we specify 2 of the variables, we can find the 2 remaining unknown variables. Okay, for the first part, there are 6 different ways in which to combine the 4 variables. So there are 6 ways. So we can relate these variables. So whatever, you can use any of these parameters to solve the equation, to solve the problems or examples. Okay, the first line you see 2 equations, V1 as functions of I1 and I2, and V2 you see as function of I2 and I1 and I2. We call this first line equations Z parameters. Z11, Z12, Z21, and Z22. And the second line you see another 2 equations. We called Y parameters. Why Y parameters? Because we use Y to relate currents to voltages. The third line, A parameters, to relate V1 to V2 and I2, and I1 to V2 and I2. And then we use B parameters, and after that H parameters, and then G parameters. So there are 6 ways or 6 parameters So to relate the voltages and currents from one port to another port. For example, what is Z11? So we have the circuit in the S domain. We have two currents, two voltages. And what is Z11? Z11 is the ratio of V1 to I1 when I2 is 0. So there is no current over here. We assume there is no current. So from there, we can calculate Z11 because Z11 is voltage divided by currents. That's why the units we use over here is ohms. And what do we call Z11? Z11 is the impedance seen looking into port 1 when port 2 is open. Okay, when we say port 2 is open, it means I2 is 0. There is no current entering the port number 2. Okay, Z12 is V1 divided by I2 when I1 is 0. Again, units ohm. Why? Because voltage divided by current. The units will be ohms. So what is Z12? Z12 because it's V1 voltage at input port to current, which current at which port? Second port or output current. That's why we call it the transfer impedance. So that's why we call it transfer impedance. So it is the ratio of the port 1 voltage to the port 2 current when port 1 is open. So when we say port 1 is open, it means I1 is 0. And after that, Z21 is V2 divided by I1 when I2 is 0. So again, because this is V2 divided by I1, we call it transfer impedance. And because I2 is 0, it means port 2 is open. And the last one is Z22. V2 divided by I2 when I1 is 0. So we call it the impedance seen looking into port 2. Why? Because this is V2 divided by I2 when I1 is 0. It means port 1 is open. When port 1 is open. So I1 is 0. Any questions? So this one was just explanation on Z parameters. This one. Z11, we have 4 Z parameters, Z11, 12, 21, and 22. Example, find the Z parameters for the circuit shown below. So we have this circuit, and we want to find the Z parameters for this circuit. So this will be our network. So we have I1 and V1. These are our input ports, and these are our output ports. So we have purely resistive circuit, and it is in the S domain. Okay, what is Z11? So if the question asks you to find the Z parameters, it means we have to find 4 Z parameters, Z11, 12, 21, and 22. So Z11 is V1 divided by I1 when I2 is of 0 or port 2 is open. So there is no current over here. So if we don't have current over here, we have a resistor, 15 ohm resistor in series with 5 ohms resistors over here. So 15 plus 5 will be 20. So this 20 will be in parallel with this 20 resistors. So the equivalent impedance, or for this one, because this is purely resistive, resistance will be 10 ohms. So V1 divided by I1 is Z11, which is the equivalent resistance you see over here, 10 ohms. Questions? Yes.
Why did we get 20 and 5 and 2 and 3?
Okay, that's a good question. Because, Anish, right? Arch. Arch. Okay, sorry. Ask why we, where's the, okay, why we said that 5 is in series with 15 and the equivalent resistance, which is 20, is in parallel with this 20. Why not 20 plus 15 and the equivalent 25 is in parallel with 15? Why not? Okay, you can see over here, for calculating Z11, we assume that there is no current over here at port 2, I2. So there is no current over here. But port 1, there is a current entering. So when the current at port 1 is entering, there are two branches. One is this, another one is this. Is that clear? But for this one, I2, there is no I2. So these two resistors will be in series. Okay, clear? Okay, that's why we calculate Z11 like this. Yes.
How do we know that port 2 is open? It isn't given in the question.
No, it's not given. You have to know it. Why? How to calculate Z11 from this equation? Z11 is V1 divided by I1 when port 2 is open or I2 is 0. Okay. So how about Z21? What is the equation for Z21? You have it. Z21 is, what's that?
V2 over I1 when I2 is 0.
When I2 is 0. So when I2 is 0, we need to find V2 over I1. So use voltage divider. So what is the relation between V2 and V1? V2 is V1 divided by 20, 5 plus 15, multiplied by 15. So this will be 0.75 V1. So V2 is 0.75 V1. And how about I1? What is I1? I1. I1 and V1. Because V2, now we wrote V2 as a function of V1. Write I1 as a function of V1. How do you write it? We said V1 divided by I1 is 10 ohms. So I1 is V1 divided by 10 when I2 is 0. Is that clear, Eric?
Where did you get the V1 voltage 20 by 20?
Where is it? Which line? This line?
Yeah.
This is Z11.
Yeah.
The equivalent resistance. Because, one more time, Z11, we use this equation when port 2 is open or I2 is 0. Okay, there is no current over here. So what is V1 divided by I1? Whatever resistance you see over here. Okay, so 5 is in series with 15. So we get 20 ohms. And this 20 ohms is in parallel with this 120. So we'll get 10 ohms. So V1 divided by I1 is 10 ohms when I2 is 0. So I1 is V1 divided by 10 when I2 is 0. Okay, for the second part, finding Z21, Again, we have I2 0 or port 2 is open. So V2 divided by I1. So we have I1 as a function of V1, which is V1 divided by 10. How about V2? Write the voltage divider over here. So you find the relation between V2 and V1, or you can write V2 as a function of V1. So you have 0.75 V1. So these two V1s will cancel out each other. You will get 7.5 ohms for Z21. Clear? Questions?
Why don't you use the one I thought that you guys had being one of the difference between Eagle Island.
Yeah, over here.
Yeah,
Why V1 over 10?
yeah, instead of the Eagle Island.
I don't see 20. There is no 20.
Well, I11 equals V1 over 20.
Difference between I11 and
Okay, this is, I wanted to show that how to calculate. If some students don't know how to use voltage divider, I just put over here to show the explanation. Okay, it was your question? This is I11. What is I11? This is the current, I11. This is different from I1. So what we are looking for I1, not I11. Okay, Z22 is V2 divided by I2 when I1 is 0. Okay, now I1 is 0. I1 is 0. So V2 divided by I2. Now 20 ohms is in series with 5 ohms. And 25 ohms is in parallel with 15 ohms. The answer for your question. Okay, is that clear? So Z22 is V2 divided by I2 when I1 is 0. So we have 20 ohms in series with 5 ohms. And this 25 ohms is in parallel with 15 ohms. So we'll get 9.375 ohms for Z22 when I1 is 0. Okay, what is the last one? Z12. What equation we have for Z12? V1 divided by I2 when I1 is 0. So again, when port 1 is open, what is the relation between V1 and V2? Use voltage divider. So V1 is equal to V2 multiplied by 20 divided by 5 plus 20. So V1 will be 0.8 V2. So we have 0.8 V2 from the previous step. We calculated I2, which is V2 divided by 9.375 ohms. So we get 7.5 ohms for Z12. Questions? Okay, these are the equations for different parameters, for 6 parameters. For Z parameters, we have the first line equations. This is for Y parameters, A parameters, B parameters, and H and G parameters. So practice example 18.2 assessment problems, 18.1, 2, and 3. Okay. For quiz or exam, you don't need to memorize any of these equations. I will give this formula sheets to you. So these are for Z parameters and different parameters like A, Y, G, H, and B. Yes.
Is that set of formulas already on Brightspace?
I will post. Okay, relationships among the two port parameters. So we have different parameters. For example, we have A parameters, how to calculate Z parameters while having A parameters. For the first part, for example, to find the Z parameters as functions of the Y parameters, we first solve these two equations. We have them over here. So we have I1 in Y parameters and I2 equation is y21 v1 plus y22 v2. So for v1 and v2, then we compare the coefficient of I1 and I2. So use Cramer's rule. From here, we find v1 and v2. And we have v1 and v2 equations in Z parameters. And we compare these two equations and these two equations. So from here, V1 is y22 divided by delta y multiplied by I1. So this one is V1 is equal to Z11 multiplied by I1. So this one, Z11 is equal to this. So plus Z12 multiplied by I2. So Z12 is minus Y12 divided by delta y, where delta y is this. Again, in a similar way, for V2, we have Z21 multiplied by I1 plus Z22 multiplied by I2. So here we have V2 something multiplied by I1 plus something multiplied by I2. So the first coefficient is Z21 and the second coefficient is Z22. So with this procedure, we have Z parameters as functions of Y parameters, like this. Questions?
What's substituting y?
What, delta y?
Yeah.
Okay, delta y is y11 multiplied by y22 minus y21 multiplied by y12. Determinant. Again, for example, if you want to find the Z parameters as functions of the A parameters, again, we do a similar way to find Z parameters as functions of A parameters. From here, the formula sheet. Okay, you have parameter conversion table. Okay, for example, zip11 as a function of y parameters will be this. or A parameters, we use this equation, P parameters use this, H parameter use this, and G use the last one. I will pass you this table, don't worry, don't memorize anything. But learn how to convert, okay? For example, from Z parameters to A parameters. Example, we have two sets of measurements on a two-port resistive circuit. Okay, the first set is made with port 2 open. So when we say port 2 open, it means I2 is 0. So for the first port, when we say port 2 is open, so I2 is 0. We have this set of measurements. And the second set is made with port 2 short circuit. Means when we say port 2 is short circuit, it means, sorry, this one is port, yeah, port 2 is short circuit. It means what? It means which voltage is 0? Yes, V2 is 0. So find the H parameters of the circuit. So to find the H parameters, okay, use this formula sheet. You have 4 equations for H parameters. Okay, so H11 is V1 divided by I1 when V2 is 0. So H11 is V1 divided by I1 when V2 is 0. So I should use this set of measurements or this one for calculating H11. What's that? The short. Okay, when V2 is 0, so we use this set of measurements. So you have the value for V1, you have the value for I1. From here, you can calculate H11 is 1.2 kilo ohms. So H21, again, use this formula sheet. H21 is I2 divided by I1 when V2 is 0. Again, because V2 is 0, we use this set of measurements. We have value for I1, we have the value for I2. So I2 divided by I1 will be 50, no units, because both are currents. So H21 will be 50. How about H22 and H12? H22 is I2 divided by V2 when I1 is 0. How do you calculate that? We don't have any measurements over here to give us the values when I1 is 0. You see over here, H12 and 22. So H12 when I1 is 0 and H22 when I1 is 0. So which set of measurements can I use for Which one?
No.
Neither of them. Okay, so how can I calculate?
You use one of the parameters.
Yes. I can use the conversion table. So I can use A parameters, for example. Okay, so what is the relation between H12 parameters as functions of A parameters? So you have the table. From the table, you can calculate H12 and H22. So H12 is delta A divided by A22. So what is delta A? A11 multiplied by A22 minus A12 multiplied by A21. So you need to have the values for all 4 A parameters. So A11 is V1 divided by V2 when I2 is 0. So you have two sets of measurements. Which one? When I2 is 0, so you will use this set of measurements. Okay? So from here you can calculate A11. Again, A21 is I1 divided by V2 when I2 is 0. So which measurement? Again, the same measurements we use to calculate A21. A12 is negative V1 divided by I2 when V2 is 0. So we have the set of measurements when V2 is 0. So find the values for that. V1 and I2. So A12 is minus 24 ohm. And A22 is minus or negative I1 divided by I2 when V2 is 0. So you have the values for all A parameters. From here you can calculate H12 and H22. These are the values for H12 and H22. Questions? That is why sometimes we use conversion between the parameters, different parameters. Tyler? Okay. So practice example 18.4. Okay. Sometimes when we use two-port circuits, they are reciprocal. Why do we use them? First, we need to learn why, how, and when they are reciprocal circuits. If the interchange of an ideal voltage, you have an ideal voltage source at one port, and you have an ideal ammeter at the other port. So if you interchange these two, you will get the same reading from the ammeter. So you can say that this two-port circuit is reciprocal. For example, for this circuit, if ammeter is at the output between these two terminals, C and D, and this source, voltage source, is between A and D terminals. So write the node voltage over here. You can calculate VBD, voltage at this node, which is 5 volt. So from here you can calculate I, which is 1.75 amp. Now if you interchange, you put the ammeter over here and the voltage over here, this voltage source, and you calculate the current in this branch. So again, ammeter reads 1.75 amps. So you can say this network or this two-port circuit is reciprocal. So a reciprocal two-port circuit is symmetric if its ports can be interchanged without disturbing the values of the terminal currents and voltages. For example, we have over here, if this reciprocal two-port circuit is symmetric, why? If we change the ports or interchange the ports, if we put V2 over here and V1 over here, again, the values for the currents and voltages remain the same. Okay, why? Because we have over here ZA and Z over here and ZB is there. So if I put V2 and I2 this side and V1 and I1 over here, so the values for these voltages and current will remain the same. So that's why this one is symmetric. So this one we call it T. The next one is pi. So in pi you can see it is ZA, but these two are ZB. It means the impedance in these two branches are the same. And for bridge T, ZA, ZA, ZB, and this is ZC. And for the last one, we have ZA over here, ZA over here. It means these two branches have the same impedance, and these two have the same impedance, the ZB and Z. Questions? So why do we need to know whether they are symmetric or reciprocal? Because they make our calculations very simple. Why? When we have a reciprocal two-port circuit, Z12 will be equal to Z21 and Y12 will be equal to Y21 and delta A is 1. So from there we have delta B will be 1, H12 will be equal to negative H21 and G12 will be equal to negative G21. So if this reciprocal two-port circuit is symmetric, so Z11 will be equal to Z22, 111 will be equal to Y22, and we have delta G1, delta H1. Practice assessment problem 18.5. Sometimes when you analyze a two-port circuit, the circuits are terminated. And when they are terminated, there will be 6 characteristics which define its terminal behavior. So the first one is the input impedance, which is V1 divided by I1. So this is the circuit two-port network. So you can see over here, this is terminated and this one is terminated. So this is connected to the load impedance and this one is connected to the generator. So we have over here ZG, which is the impedance of this generator. And the input impedance is V1 divided by I1 and the output current, the Thevenin voltage and impedance with respect to port 2, current gain I2 divided by I1 and voltage gain V2 divided by V1 and voltage gain V2 divided by VG. Example, So we have this circuit. You can see when we have this circuit, you see this is a two-port network, two-port circuit, and this is terminated, this is terminated. So you have B parameters over here. This is a set of measurement. Find the phasor voltage V2. So we want to find V2. So we'll go to this formula sheet. Use this table. Okay, so we have B parameters. So this one, this section, we have over here. So there will be two ways. The first way is find I2. Then because we have the value for 5 for this resistor, which is 5 kilo ohms. So from here, we calculate I2. We have the value for this resistor. So V2 will be negative I2 multiplied by ZL. The second way will be use this equation over here and find V2 because you have the value for VG. Using the second equation, so we have V2 divided by VG equals to this equation. So what is ZL? What is ZL? ZL for this circuit? ZL is negative I2 over V2. Okay, well, how much is that now? What's the meaning of ZL? The impedance of the load. Okay, what is load over here? 5 kilo ohms. So ZL is 5 kilo ohms. So what is delta B? Delta B is B22 multiplied by B11 minus B12 multiplied by B21. So you can calculate delta B. You have the value for B12, you have the value for B11. What is the value for ZG? How much is that? 500 ohms. So you have B22 ZL, B21 ZG, and ZL. So what is the value for VG? VG. V is voltage generator. So how much is it? 500 units? Volts. 500 volts from here. So from this equation, very easily you can calculate V2. You have all other values.
So if we already knew the 500, do we have to put?
Because this is 0 degrees, that's why I just put 500. If you had angle, yes.
Yeah, but I'm just saying, did we calculate the 500? Was that given in the beginning?
Yes.
Then why did we do all the things on the bottom then?
Because we are looking for V2.
Oh, okay.
So we are going to find V2. So we don't have the value for V2. So use this equation from here.
Okay.
Why B parameters? Because we have the set of measurements for B parameters. So that's why we use this equation. So we have VG, we have ZL, we have ZG, we have all the measurements for B parameters. So V2 will be calculated. Questions? Questions? Okay, part D also, it's good. Find the load impedance for maximum average power transfer. When do we get the maximum average power transfer? You remember?
Looking at the Thevenin load, but
Yes.
inverse in the measure.
Yes, that is, we call it conjugate or star. So when the impedance of the load is equal to Z Thevenin conjugate. Why? Walter, answer. When there is no imaginary part at the load, at that time we have the maximum power. So that's why we say ZL is equal to Z Thevenin conjugate, because we want to cancel the imaginary part. Is that clear? But now, for this circuit, what is Z Thevenin? We have the equation over here. So you have the value for ZG and you have the values for different B parameters. So you can calculate Z Thevenin. So Z Thevenin is this much. So that's why ZL will be this value. Practice assessment problems 18.6. We have 5 ways to interconnect two-port circuits. First way is cascading two-port circuits. The second way is in series. So you can see like this. If you interconnect them, so you have two-port circuits in series and parallel. And this one is series parallel and this one is parallel series. You can use any of these 5 ways to interconnect your two-port circuit. Okay, for example, for this one, which interconnection we use? Which one? Cascade, yes, cascading. So you can see from here, I1 and is the input current and I2 is the output current, and I2 prime with single prime is the output current for the first circuit, and I1 prime is the input current for the second circuit. And you see over here we have A21 prime and A11 prime, A22 prime and A12 prime. But for the second circuit, you see double prime A parameters, A11 double prime and A12 double prime, A21 and A22 double prime. Okay?
You just reverse the sign from the I.
Yes. For these two, yes. So how to find the relation between these A parameters? We use the same equations we had before. So now, because V1 is A11 multiplied by V2 minus A12 multiplied by I2. So now what is our new A1 for the first circuit is A11 prime. So that's why I put A11 prime. And what is V2? Now V2 is V2 prime. These all will be prime. So as you said, Walter, I2 prime is equal to negative I1 prime. So you use all these equations. Finally, you will get this equation for I1. So the relation between I11 prime and I11 double prime will be, you have to use these four equations if you have cascading two-port circuits.
Are these formulas provided too?
Yes. Oh, here, okay. So practice example 18.5 and assessment problem 18.7. That's it for two-port circuits. Do you want me to solve practice or any examples of assessment problem, or you want me to solve it for you on Monday? Because you have midterm, I don't want to take time for you right now. It's up to you. Monday? Okay, Monday. So best of luck. And if you have any questions, come to me. If you want me to review your papers, you have it right now, come to me right now or on Monday, okay?
Yeah, so here is my so I only got 1 point for the first question, but I reviewed it. The only thing I did wrong was I was being dumb and I didn't get rid of that. But everything else, like all of this is right if I corrected a mistake.
Yes. So for where is the value for I? You got how much you got? Okay.
Yeah, I compared it with the solution. I carried that mistake through.
Okay. So this is 4. This question 5. Okay. So I will give you +3 over here.
Thank you. Yeah.
And
I was so confused when I got it because I was like,
yeah, I know it's not
Yeah.
fair. It wasn't fair.
and I got full points.
Okay.
Okay.
So
Thank you.
+3.
Perfect. Thank you.
So would you please scan it and send it to me by
Yeah,
email so I
for
can
sure.
change your grade?
Thank you.
No problem.
Hi.
Yeah. Yeah,
So
the same problem, right?
yeah, for me it was just
How much you got for this?
they took off 3 points.
Okay.
Okay, and it was just
Because
like
just for the final answer?
yeah, it was just the final answer. So like the process was right. Going back and checking it if it was just all right.
Again, please scan it and send it to me by email.
Sure. Thank you.
I was mostly curious about what circuit configuration shown in this picture.
Okay.
I only got 1 point, so I couldn't do any stuff from here, but I explained it.
Okay, so how much you got? You got just 4?
Yeah.
Okay. Plus 1 over here, and then how about the second question?
And I just wanted to ask, I'm not 100% sure. I did it, like I just calculated the equivalent resistance of the circuit and then got the current that way. But I ended up getting the wrong number. Not sure.
So because of this value.
Yeah.
And how about the opposite? This one also is wrong.
Oh, is it?
Yeah, this is minus. So how much you got for this?
I just got 2.
I'm not doing that.
Oh, okay.
I'm not doing that. I don't care.
Because this is also wrong. This one
I don't care. I'm not doing it.
2.5.
I'll never do it. Okay, left one makes sense.
Scan it and send it to me.
I sent it to you?
Yes.
Okay, perfect. Thank you.
Okay, this is the and how about this one?
I was doing this as a semester, so I'm not sure if it's
Wrong, this is wrong. It's not.
Yeah, I see that.
And how about the other?
the other one. I don't think it was as well. I got the first 2, but I didn't know how to solve that one. So.
got the note. Okay, this is good. So how much I give you 2 for that? Scan it, okay, and send it to me by email so I can change your grade.